So right here we have another condensed logarithm that we're going to expand. And this one's a little tricky because you do have the multiplication between the variables and then division. So when you expand it, you know that they're going to have addition when it's multiplied like that, and division, subtraction when it's divided. But that function a squared b divided by c to the fifth is actually trapped right this second inside of a cubed root. Um, I want you to realize that the cubed root is the same thing as the 1/3 power. So if we think of that as a 1/3 power, I can apply the power rule from the very start and say 1/3 in the very front, the logarithm of a squared b divided by c to the fifth base a. But now I need to keep on. Now that a squared times b divided by c to the fifth, now that it's no longer, now that I no longer have to worry about the cubed root or the 1/3 power, I need to expand this logarithm. So, let's see. Because you have those three variables, you know that you're going to have three logarithms. So, log, log, log. And they're all going to have the same base A. And when the log of a, since it's a squared, that 2 can come in front. B doesn't have an exponent, and C had a 5, C to the fifth, so the 5 can come in front. Now, since the C to the fifth was in the denominator, remember anything in the denominator gets subtracted. And the A and the B were multiplied, so when you expand that, they're added. But you can't forget about that 1/3 that you put in the very front, because the 1/3 was the cubed root from the very original problem. So now all we have to do to finish this expansion is distribute that 1/3 to every single logarithm. And it's not that bad. When you say 1/3 times 2 logarithms of a base a, then it becomes 2/3 logarithms of a base a, plus 1/3 times the logarithm of b base a is 1/3 logarithms of b base a. There wasn't a constant in front of that logarithm to multiply it by. And when I say 1/3 times 5, I get 5/3 logs of c base a. Basically, all those constants, I just put them over 3 since you multiplied it by 1/3. This is expanded. I do see one thing, one more logarithm rule that we can apply. And that is whenever you have the logarithm, whenever the logarithm and the base are the same exact variable, or they're the same variable to the power, whenever they're the same thing, they cancel out. So this log a base a right there cancels because it's the logarithm of a and it has the same base. So you could just write as 2/3 plus 1/3 logarithms of b base a minus 5/3 logarithms of c base a.